Let me see. I think I can force myself to. So I end up with trying to use Google Good Notes. So let me see. Yeah, here you go. Is this good enough? Do you see? Okay. So I can, when I use it, I'm gonna use this, but not to bother. Okay. Yeah, sure. Yeah. So then, Victor, I have one more question. What I was thinking. So when you do this, even if you do just a two-step or three-step, it still improve, I believe, the finite sample bias or asymptotic variance is going to be shrink, right? Because if you use this, spectral radius is going to be smaller. So even two-step or three-step should work better than just a simple two-step without doing it. Yeah, but my question is that to compute that alpha k, you have to take a Jacobian with respect to p, which is costly. So I'm just wondering, oh no? Oh, you don't need it? Oh, really? Okay. Oh, really? It's, oh, I see. Oh, okay. 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 So if that's the case, that's very good. Okay, good. Yeah. Thank you. So this is just joint work with Paul Shrimp and Michio Suzuki. So the motivation is that so there's a many empirical study that does estimate the production function, and in particular, often people are interested in recovering TFP from estimated production function. In most applications, the coefficient of Cobb-Douglas production function are assumed to be common across forms. And then in this paper, we are questioning about this assumption of the commonness of this beta m, beta l, beta k across different forms within the so-called narrowly defined industry. So the one implication of those commonality of the coefficient is just like original Soro residual is computed. You can think about material shear. Well, material shear could be subject to the difference in the markup. So we can also look at assuming that labor is flexible, at least in the long term. You can think about, rather than looking at material shear, you can look at the cost share of the material where the denominator includes the material cost and the labor cost. Okay, if there is no heterogeneity beyond the Higgs neutral productivity, the empirical counterpart of those material shear and then the cost share of the material should be very similar across forms. Okay, in fact, and I'm going to take a long-term average within each firm. So, but if you look at actual data, so this is a Japanese manufacturing census data at the 4-digit industry level, looking at the concrete product, which is one of the most homogeneous product, I believe, within the 4-digit level of the classification, and the electrical audio. Yeah, so electrical audio, you can imagine there's a very different product even within the 4-digit, and you expect that. So this long-term average of material shear for at the farm level empirical distribution shows the heterogeneity is really large, okay, larger than what I think before, what I thought before I see the data. Even concrete product, if you look at like 90%, 10 percentile, 90 percentile, you still see there a lot of differences. So even the one of the most homogeneous product, you see the material share being different, okay? You can look at also the cost share defined by the material divided by the cost, sum of the material and the labor cost. You still see a lot of heterogeneity, so it's not coming from the markup differences. One way to gauge how you going down to the industry, final industry classification helps or not is going to be actually you look at the 2-digit and the 3-digit and the whole digit. But it turns out that in the case of, say, electric audio, going down the final industry classification does not help controlling for heterogeneity at all, okay? So I don't have a 5-digit classification, but I imagine that even if you go to 5-digit, you're not going to see much of the differences. You can repeat this across all the different industry and then look at the average value of those 90% to 10% differences. So as I said, electric audio tend to be one of the most heterogeneous one, but across all other industry classification, going down the final digit does not seem to control for heterogeneity as much as we hope. Okay, so this is provide evidence for the heterogeneity beyond Higgs-Neutron productivity. Okay, one argument that what's missing is maybe this Cobb-Douglas assumption is wrong because we know the capital is very sticky variable and doesn't change over time. So maybe you can go beyond the Cobb-Douglas, and then that implies that material share is going to be a function of the labor and the capital and the material. So even after you control for it, you take the residual of the regressing the material share on the second order polynomial of LKM and get the residual, take the weighted long-term average, so that represents the residual part of the technology. And then if you look at the 90 to 10% differences, it doesn't reduce much. So this is the evidence that there's a persistent heterogeneity is there, even you go more general function than Cobb-Douglas. You wanna, yeah, sure. Over the longest one is 25 years. Yeah, across farm, not after wiping out the idiosyncratic shock. Yeah, even more variation if you're gonna. Okay, so the issue is then given this evidence of a big heterogeneity, can we actually identify the production function in the presence of unobserved heterogeneity? Can we estimate the production function with random coefficient using a typical farm plant level panel data? And then that identification issue, I believe that many people suspect this, although that I believe that our paper is the first one that present the evidence cited as facts like this. But I guess that the main issue is really, okay, even if we know it, it's very difficult to identify production function from the data, given the typical data we are available. In the interest of time, I'm not going to talk about vast literature of the production function, but I just point out that the Gandhi-Navarro river have the argument that there is an identification problem if you use a control function approach, and then they exploit the first order condition with respect to the first flexible inputs as an additional restriction to recover identification. And that's the identification strategy we're going to use too. And then also that the literature on identification production function with random coefficient has very limited to identification results. So our paper's contribution is that we're going to present identification results under the unobserved heterogeneity beyond the Higgs neutral production function, and then the proposed maximal likelihood estimate under normality assumption, and then show the empirical application using Japanese census and manufacturing data. So first, non-parametric identification. We're going to think about the panel data. Typical panel data we can get access to, which is there's output, number of workers, capital stock, intermediate input. Importantly here, we're going to also use total wage bills to control for the potential heterogeneity in the quality or number of hours of the workers. Okay. The K is assumed to be predetermined for simplicity. And then that LT, which is the number of workers, and the M intermediates are assumed to be flexibly chosen. Okay, and then the I represent the information available for choosing L and M. So we're going to think about a mixture model where there are unobserved types. There are the cap J unobserved types. Pi J represents the population fraction of the type J. Okay. And then we're going to think about the non-parametric identification, so that we are thinking about production function FTJ, or in fact I have here. So we're going to think about production function FTJ. Notice that we got T subscript there, and the J represents the heterogeneity of type. So we are potentially thinking about time varying production function over J. And then we're going to think about the autoregressive process potentially. But here it's a little bit more general, just first order Markov process. Importantly, we're going to think about capital is going to follow the Markov process condition on the previous capital and the productivity, which is typically implied by the typical model macroeconomists is going to write for investment decision. No, it's a sequence, so the type is defined as a sequence of production function over time. So that each type is defined as a sequence. Yeah, and it gets, yeah, right, but a sequence is defined. The sequence defines the type. Okay, so LIT here is going to be different for observed number of worker because there is a potentially difference in the quality and the hours. Okay, so I'm going to model the difference in the quality and the hours through this psi tj. Okay, and I'm going to I'm going to identify this unobserved quality and hours using the total wage bills. Okay, and essentially the average wage should gives you the some information about the difference in the quality or hours working. L and M are flexible inputs, and so we're gonna extend this monotonicity argument typically used for the control function for the M and L. And importantly, this flexibility of L and M is gonna give you the endogeneity issue, which is the most important issue for the identification of the production function. We're gonna exploit first order condition as a extra identifying restriction. Okay, so this is just a very general way of writing the first order condition for M and L. Okay, and then this gives you the source of identification. And this is a strategy used by the GNR, Gandhi-Nebar River, to recover the identification of the production function when there is no unobserved heterogeneity beyond the Higgs neutral technology. Okay, so main identification result, which I'm not going to get into here because of the time constraint, is that we can actually non-parametrically identify the type-specific technology term. Okay. as well as all the distribution, which is a type specific across all types. Okay, and then we claim that we only need 4 periods of data for identification as long as the number of forms goes to infinity. In particular, we can think about Cobb-Douglas case. So if you look at this first order condition, it's complicated, but Cobb-Douglas case is very simple. Okay, and then this is a specification we're going to use for the empirical analysis. Note that there is one more equation coming from the wage-bill equation. Okay, so that's going to give you the identification of the quality differences or hours difference, which we don't observe in the data. Okay, and then there is output production function. So taking this 4 equation, we can construct the maximum likelihood estimator by assuming all those terms are normally distributed. So estimation. So we're going to consider 2-stage parametric maximum likelihood estimator by adding a parametric assumption, which is essentially normality assumption, because this is so we need to also consider the initial condition to do a maximum likelihood here, and then we're gonna make also a normality assumption there. Okay. Still, the computation, this is very heavy. Okay. Multivariate mixture model, even under normality assumption, is heavy with many unobserved type. So we're gonna use a 2-stage parametric MLE, so we can decompose the type specific probability density function into 2 parts. First part is the share equation part, which has a very simple form, and then that second term is going to be including the more complicated part. So the idea is that we're going to estimate the subset of the parameter using the relatively simple likelihood, and then given that first stage estimates, fixing it, we're going to do the second stage for the subset of the parameter. Okay. Advantage of the 2-step parametric, so our identification has an advantage over the classification method. So if you have a long T, you can actually do the classification like k-mean, or even the first stage maximal likelihood estimator gives you the likelihood of which posterior type specific posterior can be used to classify the different form into different types, which is much simpler and easier, but that requires a long cap T. Okay, but as for short cap T, you can use MLE to do this. Okay, so let me talk about empirical application using Japanese census manufacturing data. So data set is I think typical. Yeah, so this is a typical data. Okay, so we got capital stock, number of employees, material, and the sales. We're gonna focus on the electric audio equipment, which contains 900 plus plants. Okay, and then different plants has a different lengths of it's an unbalanced panel. Okay, so specification wise, we're gonna think about 3 types for the coefficient of the output, and then for within each of those production type, we got different types of the high and low type in terms of average wage, essentially. So that represents the each output production type. There are 2 high and low hours and the quality type. So in total, there's 6 types. So we're gonna have estimates of production function. So when we assume the production function being homogeneous, we have a very low scale return to scale, which is 0.65. Once we introduce the heterogeneity, we have a little bit bigger return to scale. It's, I think I'd say, more reasonable one. Also, there are three different types of the production function. And as you see, that material shares are very different across three types. Also, the labor shares are very different. Okay. As a result, that if you look at the capital labor ratio, there's a vast differences in terms of capital labor ratio across different three types. Within each type, you got a very high and low wage farms, the average wage farm that represents capturing the hours or quality differences in the labor. Okay. We can, using the estimates, we can compute the posterior probability of each of type, each of farm you can compute, and then that can be actually used to classify the farms into the 6 different different types. You got the 6 different subset, and then you can actually do whatever you like, so that by product you can get the classification of the farm, and within each subset farm you can run the additional empirical analysis to exploit the output of this empirical methodology of the estimating the different types of technology. Let me do the 2 more slides. So we'd like to investigate the implication of what we estimated. And so one thing is that we can exploit the forward-looking behavior. Okay, so we extract the TFP out of this. Okay, and this is a typical empirical analysis whether TFP matter for investment or not, TFP matter for export decisions or not. Okay, if we are correctly recovering the TFP, we should observe what we expect. Okay, so so if you use the TFP under the homogeneity, you got the 0.5, so that the investment is responding to TFP, which is good. But depends on which type you are talking about. Turns out that the investment response to the TFP is very different, so that you can actually investigate the difference in elasticity of the TFP to the investment across different types. Okay, in particular, the larger, so the high material share, high capital labor ratio farm tend to respond to TFP in terms of investment. You can also look at the quantile regression of this, and then you see that especially the high quantile investment farm, that the TFP is going to be explain the investment of the high quantile part, especially for the latter 2 types with the high material share, high capital share. Okay. I think this is it. So in conclusion, we show the stylized evidence for the heterogeneity beyond the Higgs neutral term, and then that we provide a non-parametric identification of the production function estimation and the heterogeneity, propose the maximum likelihood, show the empirical application, and then also we show the evidence that the investment or export elasticity, we do that also export elasticity too, are going to be different across unobserved types. And thank you. Mm. Mm. That's a good question. So yeah, let me think. So material share, so that you can think that like here, right? So implicitly you can think about here material share is written as a common, but you can add I subscript, right? It doesn't change the identification of at least the share equation, I don't think. Okay, so you can allow. Go ahead. Well, it's a price are given to farm, right? I mean, yeah, okay. So yeah, monopsony power is maybe different. Then the elasticity, first order condition is going to be different, right? But yeah, I understand that. Yeah. So if it's not monopsony power, if it's a given, I think it's fine to have a IID shock to the price because the share equations restriction seems to me that doesn't change. If you got the monopsony power or monopoly power, first order condition would be different, so it does not gonna apply unless it's a CS structure. So that in that case you're gonna have just a difference in the level. But other than that, I don't think we can do this. Yeah. Okay. So right. Right. Okay. So so for example, if you look at this output equation, so all the price is gonna be in epsilon, or if it's a type specific, it's gonna be here. Okay. So yeah, I think it could be that if it's not IID, if it's persistent and the different across types, it's gonna be in here, I think. Yeah, yeah, yeah. So actually, the with graduate students who's going to be hopefully on the market, if the market is not bad, yeah, if there's a market. So Jasmine Howe, I'm working with her to write a paper on how to test the number of types exactly in this context.